Hello everyone, welcome to the 16th video lecture of class 9 science. In this we will be starting with our fourth unit, that is electric charge and electric current. In particular, we will be dealing with the concepts regarding electric charges, electric force, electric field and electric field lines. We know that the matter is made up of atoms and molecules. Atoms have particles like electrons, protons and neutrons. By nature, electrons and protons have negative and positive charges respectively, and neutrons do not have any charge. That means we all know all the matter around us are made up of atoms and molecules, and these atoms contains particles like electrons, protons and neutrons. So these electrons has got the negative charge in it, and the protons has got positive charge in it, and the other one, that is neutron, does not have any kind of positive or negative charge. So it is called as chargeless particle. Like mass and length, electric charge also is a fundamental property of all matter. Like if there is an object, we say that the object has 5 kg of mass, or the object is 5 meter in length. Similarly, any particle, if you go for any particle like electron or proton, we say that the electron has got this much of mass, the electron has got this much of radius, and electron has got this much of negative charge. So, like mass and length, the charge, the electric charge, is also one of the fundamental property which we have already seen in our first unit. An electric current consists of moving electric charges. That means we all have heard about the word electricity or electric current. So what is it about? From where it comes into picture? So whenever there is a movement of any electric charges, if these charged particles starts to move, then we say that there is an electric current. Electricity is an important source of energy in the modern times. So these days we cannot live without the electricity, right? The electricity has become one of the important part of our day-to-day life. So that is what is the importance of electricity in our life. For anything, for any purpose, for every activity, we require electricity. Okay, so because of that, we have come up with so many different methodologies to obtain the electricity, maybe from wind or water, from solar, whatnot. From all the possible ways, we are obtaining the electricity because it has got such an important role in our day-to-day life. So this chapter we will be studying the some of the concept roaming around the concept electricity and electric current. So what are the things which are related to electricity or electric current, how actually it works and how actually it is produced, generated, everything we are going to see in this particular chapter. So starting with, we said this electric current or electricity is nothing but the movement of any charged particle, electric charges. Right. So first we will be starting with what are these electric charges. Okay. So we are actually familiar with this, but we didn't call them as electric charges till today. We just called them as charged particles, like negatively charged or positively charged, nothing but the electrons or the protons. They are called as the electric charges. Okay. So as we said, you can see here it's a model representing the atom. So at the center we can see there is a ball kind of structure of red and blue color. Both combinedly have formed one particular substance at the center, and some of the yellow balls or the yellow particles are revolving around them, right? So the thing which is at the center is nothing but the nucleus of the atom. Inside each atom there is a nucleus with positively charged protons and the chargeless neutrons. So this yellow, sorry, not yellow, this red and blue particles, what we can see, this whole forms the nucleus. This whole thing is the nucleus. Okay, this nucleus actually contains two type of particles. One is positively charged protons and the other one is chargeless neutrons. That's why they have represented with the two colors, because the nucleus contains two things. One is proton and the other one is neutron. Okay, the yellowish thing which is revolving around the nucleus is nothing but the other one particle, the remaining one, which is it is the negatively charged particle, that is electron. Okay, so you have to remember, nucleus contains two. In an atom there is a center part, right? That center part is called as nucleus, and inside that nucleus there will be two particles. One is positively charged proton and the chargeless neutron, and outside the nucleus, okay, there are neutrons revolving around the nucleus. Okay, so whenever we talk about number of, okay, how many electrons or how many protons are present in any atom, usually in any atom for that matter, any stable atom you take, it will be having equal number of protons and equal number of electrons. Okay, the number of electrons will be always equal to number of protons in a neutral atom. Since it has got same number of neutrons and same number of electrons, sorry, not neutrons, same number of electrons and same number of protons, we say that the atoms are neutral in nature. Okay, they are neutral in nature or stable in nature. If an electron is removed from the atom becomes positively charged. For example, there is an atom containing 10 electrons and 10 protons. Now I remove one electron. So now what will be the total charge? Like 9 electrons will be there, 10 protons will be there. So 10 protons will dominate these 9 electrons. If they are equal, the atom will be neutral. If one is missing, like one electron is removed, now it is 9 electrons and 10 protons. Proton has got a charge, positive charge. So what happens? It will be positively charged. That means the positive domination will become more on it. You have to remember it like that. Okay, so the atom will become positively charged. So this, then it is called as positive ion. Now, if the reverse thing happens, now there were 10 electrons and 10 protons. Now I go and add one more excess electron. Now the electrons will become 11 and the protons will be still 10. So now the electrons are larger in number. What happens? The electron will dominate. So the negative charge will dominate. So the atom will become negatively charged. And it is called as negative ion. Okay. Usually number of electrons and number of protons will be equal in an atom, so they are called as neutral. So by any means, if you remove any electron, then the atom becomes positively charged and it is called as positive ion. By any means, if you add up one more electron to that atom, then the atom becomes negatively charged and it is called as negative ion. Okay, this is about the brief introduction regarding the electric charges. Okay, there are electrons and protons and neutrons, where electrons are negatively charged. Sorry, protons are positively charged and the neutrons has no charge in it. Okay, so 3 things we have learned. How actually we measure this electric charges? We said that electric charge is also one of the fundamental quantity. If there is any particle, for example, the electron is there. How much charge the electron contains? Like electron has this much of mass, we can say. this much kg it weighs, or it measures this much kgs of mass. Or it has this much radius, this much length of radius it has got. So how exactly we can say this much amount of charge is present? What is the SI unit? Everything we are going to see now. Okay. The electric charge is measured in coulombs, and the symbol is capital letter C. This we have already seen in the first lesson itself. The electric charge and its unit is capital letter C. The charge of an electron is numerically a very tiny value. Okay. Small value. Tiny means small value. The charge of an electron, which will be represented by small letter E, is a fundamental unit with a charge equal to 1.6 into 10 to the power minus 19 coulombs. That means one electron contains how much of charge? 1.6 into 10 to the power minus 19 coulombs of charge will be contained in an electron, in one electron. That means E is equal to, the value of E is equal to 1.6 into 10 to the power minus 19 coulombs. The amount of charge of an electron and a proton are same. The amount, how much amount of charge the proton carries will be equal to the amount of charge the electron will be carrying. Okay, but their natures are different. So one is called as negative charge, the another one is called as the positive charge. The amount is same, but their nature is different. That's why we say that the electron has got negative 1.6 into 10 to the power minus 19 coulombs. Okay, and proton will have positively charged with the value 1.6 into 10 to the power minus 19 coulombs. Okay, this indicates that any charge Q has to be an integral multiple of this fundamental unit. So we all know that charges will come into picture whenever you add or take off any electron, right? So how actually we can calculate the charge of any particle will depend upon the number of electrons and the number of protons depending present in them. If an atom contains 2 electrons, or if any object, any particle or any atom contains only 2 electrons, then what happens? The total charge will be, if 1 electron, then it will be 1.6 into 10 to the power minus 19 coulomb. If there are 2 electrons, what happens? 2 into 1.6 into 10 to the power minus 19 coulombs. If there are 3 atoms, not atoms. If there are only 3 electrons present in that, then we say that its total charge is 3 into 10 to the power minus 19 coulomb. So similarly, if there is any object containing only 1 proton, then its charge will be 1.6 into 10 to the power minus 19 coulomb. So if any like that, so always it will be multiples of 1.6 into 10 to the power minus 19 coulomb. So therefore the total charge Q is given as N into E, where E is the value equal to 1.6 into 10 to the power minus 19 coulomb, and N is the whole number. 1, 2, 3, 4. Sorry, whole number starts from 0. 0, 1, 2, 3, 4, 5, etc. Okay, so this is how the electric charge is measured, and its unit is coulomb. So we have seen that an electron contains the charge in the range 10 to the power minus 19 coulomb, a very minute value of charge, right? So for that case, always it will not be good to use coulomb. So there are other units like microcoulomb, nanocoulomb and picocoulomb. They are other units of electric charge. So 1 microcoulomb will be equal to 10 to the power minus 6 coulombs. 1 nano is 10 to the power minus 9. 1 pico is 10 to the power minus 12. So this suffix and prefix we have already studied in our first lesson, units and measurement. Just go through that. Fermi is 10 to the power minus 15. All those things. Milli is 10 to the power minus 3. Micro is 10 to the power minus 6. Then it is nano, it is 10 to the power minus 9. Then pico 10 to the power minus 12. And then Fermi 10 to the power minus 15. So, electric charge is additive in nature. The total charge of a system is the algebraic sum of all the charges located in the system. So if I have any bag containing different particles with different amount of charge, for example, there is a system containing plus 5 coulomb and minus 2 coulomb of charge. That means one system, like one bag. This bag contains 5 coulomb and minus 2 coulomb of charges. Okay, two particles are there. One particle is containing 5 coulomb of charge. The other particle is containing minus 2 coulomb of charge. Then what is the total charge of this whole system or whole bag? Then we go just for algebraic sum. Okay, so plus 5 minus 2 is equal to plus 3. So the total charge is plus 3 coulombs. For example, if the same bag contains minus 5 coulomb and plus 2 coulomb charges, then the total charge will be just a sum of these two, that is minus 5c plus 2c, it will be minus 3 coulomb. The total charge, the net charge is minus 3 coulomb in that case. Okay, so the total electric charge of a system is the algebraic sum of the charges located in the system. Okay, the next concept which we will be studying is electric force. Now we know there are two types of charges. Yes. So what happens if they are brought together? So such kind of things we are going to study now. So among electric charges, there are two types of electric forces. One is attractive and the other one is repulsive. So whenever you bring certain charges, some of them will attract, sometimes they will repel. Repel means they will push aside. Another one is they will just attract each other. So there are two types of forces coming into picture when we bring certain charges nearer to each other. So how exactly it works? The like charges repel and the unlike charges attract. So if there are like charges, that means same charges are present, then they will repel. Same type of charges will just push them away. If there are of different types, for example, one is positive and the other one is negative, then they will attract. The force existing between the charges is called as electric force. These forces can be experienced even when the charges are not in contact. You just bring them near. No need to touch them. Okay, bring them near. Even though there is no contact between these two charges, the force will be experienced. Therefore, this force is a example of non-contact force. That means the force exists even though the things are not in contact. So this is the diagram showing how the like charges repels. So you can see there are two positive charges. So when there are two positive charges kept near, so what happens? They are moving in a different direction. That means they will push aside. They will repel. Okay. Similarly, when you bring two negative charges, they will repel. They don't like each other. They are of same type. Okay, so now when we bring two unlike charges, like one is positive and the another one is negative. Unlike means different charges, like means same type of charges. Okay, unlike charges are brought, that is one is positive and the another one is negative. Then what happens? They try to attract each other. They come closer. Like charges repel, that means push away. Unlike charges attract each other. Okay. So this is about the electric force. The region in which A charge experience electric force forms the electric field around the charge. It's like, so this is a charge Q. Okay. So whenever I'm bringing one small charge Q, small letter Q, so as I'm bringing it from infinity, from so far, I'm coming near and near and near. At certain point, I start to experience the repulsion or the attraction or any kind of force due to the charge capital Q. The bigger charge will put some force. When I start to come near and near, it will start to apply some force on this small charge. So the area where this force can be felt, the effect of this capital Q can be felt by the small q, is called as the electric field. Actually, it is a area where you can feel the effect of the capital letter Q. Okay. Electric field is a vector quantity. The direction of the electric field is the direction of the force that would act on a small positive charge. So in which direction the force will be applied by the capital charge or this capital charge Q on a small charge, small letter Q, will be the direction of electric field. The electric field at a point is measure of force acting on a unit positive charge placed at that point. So how much charge or how much force will be experienced by 1 coulomb of charge at that area, at that place, will be the electric field of that charge at that place. That is, it's a bit tricky to understand. Okay, just concentrate. So I have a Q here, right? And now I am bringing one small amount of charge. So if this is 1 coulomb of charge I'm bringing. So when I'm bringing this charge, I'm at this point, I'm experiencing some force. That means I means this 1 coulomb of charge is experiencing some force from this charge in this direction. That means they are like charges, they are pushed away. Okay, in this charge, this will be the direction of electric force as well as electric field. Okay, so how much is the electric field? How you will calculate? The force experienced by this 1 coulomb of charge, okay, at this place will give you the value of electric field at this place. If you come closer, the electric field will be still larger. Here it is less. As you go near and near, you will experience more force. That means more the field. So here, if we calculate the force experienced by this 1 coulomb of charge, okay, that will give you the value of electric field at this position. Similarly here, at this point. So let us take A, B and C. At this point, if you bring the same 1 coulomb of charge, so how much force it experiences at this point will be the electric field at that point. Okay. So a positive charge will experience force in the direction of electric field, and a negative charge will experience the force in the opposite direction of the electric field. Okay. The force experienced by the positive charge will be in the direction of electric field. The force experienced by the negative charge will be opposite to the direction of electric field. The electric field is represented by some of the special lines called as electric field lines. So how exactly we represent these electric fields? We cannot actually see it, right? Only when you bring a small unit charge near to any charged particle, we can experience either repulsion or attraction. If we experience any repulsion or attraction, then we say that there is some electric charge due to which the field has been created, because of which we are either attracted or repelled. Electric field, which is represented as E, will be represented by lines and arrowheads indicating the direction of electric field. The electric lines of force are straight or curved path along with which a unit positive charge tends to move in the direction of electric field. These electric lines are imaginary lines. Okay, these lines which are used to represent the direction of the electric field, direction and the nature or the strength or the magnitude of the electric field are imaginary. They doesn't exist. They are just imaginary. Okay, these imaginary lines are used to represent the electric field around any electric charge or any electric circuit or any charged particle or object. The strength of an electric field is represented by how close the field lines are to one another. For an isolated, the first thing, the strength, if the electric field is high, then there you will see there will be more number of field lines. If the strength of the electric field is less, if it is weak, then there will be less number of electric field lines. For an isolated positive charge, the electric field lines of force are radially outwards, and for an isolated negative charge, they are radially inwards, as shown in the picture now. So the positive charge, the electric field will be going outside. For a negative charge, the field lines will be coming inside. So always remember, the electric field lines or the line of force will start. Always remember, the positive charge starts from charge. So this is the diagram representing what happens if they are not isolated, they are just kept nearer. Like there are two electric charges in a system. Okay, in that case, as we saw in the previous slide, if they are positive and negative, that means alike charges, then they form closed loop like this, as shown in the first figure. Like this, the line starts from the positive charge and it ends at -1. And one more thing you have to remember, nowhere they are touched. That means they will not intersect each other at any point. In all the diagram you can see none of the field lines are touching each other. Okay, you should be very careful when drawing. They should not touch each other. Okay, so now what happens if like charges are kept together like this? Since it is a positive charge, it is represented as going out, but they are not. See, all of them are going away. Similarly, if two negative charges are kept, all the things will be, the arrow marks will be just ulta of it, coming inside, but they will not form a loop like this. Okay, they will not be coming from one end and ending at the other end. They are going somewhere away. That means it shows they are repelled. Similarly, if you are given with any positively and the negatively charged rods like this, the green one is positively charged rod and the yellow one is negatively charged rod. So if they are kept nearer to each other, so the field lines will be from positive to negative. They will be always parallel. At the ends, they will be curved. Okay, so these are the different field lines drawn for isolated positive charge, isolated negative charge, and two charge system. That is, one is like charges, another one is unlike charges, and the last one is for uniformly charged rods. Okay, so this was about electric charges, electric field, electric force, and electric field lines. Thank you.